Good morning, Algebra 1ers. Today's lesson is from section 10.3. It's on simplifying and estimating square roots. So we have two main objectives. Our first objective is to simplify problems with perfect squares. That'll have 3 levels to it. And then our second objective is to estimate which two consecutive integers a radical lies between. You'll see at the top of my page I have my perfect squares written down all the way from 1 to 15. So I just went through and I said 1 squared is 1, 2 squared is 4, 3 squared is 9. Wrote that at the top of my page because I know that's going to be a really important tool for me throughout this lesson. So I would highly advise that you take a minute and do the same. Okay, if you need to, pause the video. So we're going to start with level 1 from objective 1. We want to simplify the following problems. Okay, so I'm writing simplify and level 1 simplifying. The first one, this is going to seem really easy and you're probably going to laugh at me, but I want to know what the square root of 64 is. And yes, looking at the chart up above, 64 is on the chart. And in fact, if you take 8 squared, you get 64. So the square root of 64 is 8. Okay? All right, number 2 gets a little bit more challenging, but not much. Not yet. Number 2 is negative radical 81. Now, really what this is saying is there's an invisible 1 in front of the radical sign, and the operation between that negative 1 and the radical sign is multiplication. So this is saying negative 1 times the square root of 81, which is negative 1 times 9. So we get negative 9. And that's our final answer. Okay, number 3, a little bit trickier, but still not too challenging yet. We've got the square root of 9 over the square root of 100. We go ahead and simplify the numerator first. The square root of 9 is 3. Then simplify the denominator. The square root of 100 is 10. Check to see if our new fraction can be simplified at all, and it can't. So 3/10 is our answer. And number 4, again, not too much more challenging. We're going to take the square root of 196 over the square root of 144. Now, some of you may not have 14 squared memorized yet, but you should by the end of this unit. Actually, hopefully by tonight, you have it practiced. So the square root of 196, if we look at our chart, is in fact 14. And the square root of 144, if we look at our chart, is 12 squared. Is 12, sorry. So we get 14 over 12, and we look at 14 and 12 and say they're both even, so they definitely can be simplified. I'm going to divide both of them by 2. And 14 divided by 2 is 7. 12 divided by 2 is 6. I check 7 and 6. They cannot be simplified any further, so 7, 6 is my answer. All right, level 1, pretty basic, pretty easy. We're going to kick it up 1 notch, and we're going to move to level 2. So level 2 questions, we are still simplifying, but they get a little bit more challenging. So problem number 5 is the square root of 169 over 25. And this is really just a disguise for the exact same type of problem as 3 and 4. It looks trickier because we now have a fraction underneath the radical, but we can split that one big radical up into 2 little guys. So it's really the same thing as saying the square root of 169 over the square root of 25. And we know according to our chart up here, the square root of 169 is 13. And hopefully eventually you won't be using that chart anymore. And then the square root of 25 is 5. So we check if 13 over 5 can be simplified, and it can't, so our answer is 13/5. Number 6, let's take negative 2 times the square root of 49. Remember, there is an invisible multiplication sign here, so I'm just going to go ahead and say this is negative 2 times the square root of 49 is 7. So negative 2 times 7 gives us negative 14. And last one in level 2, we've got problem number 7. Let's give us a little more room. Let's move it down here. Let's do negative radical 225 minus the square root of 16. Okay, so this one, bring down everything from the problem above, but let's simplify the radicals while we're at it. So negative, the square root of 225 is 15, minus the square root of 16 is 4. Keep, flip, change, negative 15 plus negative 4 is negative 19. And then we're going to boost it up one more notch. We're at the black belts. So level 3, still simplifying. Let's take negative 2 radical 36 divided by 5 radical 9. So same as before, just replace those square roots with their perfect squares. So negative 2 times the square root of 36 is 6, divided by 5 times the square root of 9 is 3. So 5 times 3. In the numerator, we have negative 2 times 6, which is negative 12. In the denominator, we have 5 times 3, which is 15. And negative 12 over 15 simplifies to negative 4 over 5. And last example problem, number 9. Let's do negative 7 radical 16 plus 2 radical 49. Again, we're going to rewrite the problem exactly the way we see it, only we are going to replace those perfect squares. So we've got negative 7 times, instead of the square root of 16, I'm going to write 4, plus 2 times, instead of the square root of 49, I'm going to write 7. And then order of operations says that I multiply before I add or subtract. So I'm going to do negative 7 times 4, which is negative 28, plus 2 times 7, which is 14, and negative 28 plus 14 is negative 14. So negative 14 is my final answer. Alright, that's all we have for our first objective, which was to simplify problems with perfect squares. We're going to now move on to objective number 2, which is to estimate which two consecutive integers a radical lies between. Now, when I say consecutive, I mean in a row. And when I say integers, it has to be a number that you would typically write on a number line. So for example, 1, 2, 3, 4, 5, 6, or negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, etc. Okay? And if you don't have this lovely chart of perfect squares written down, I would highly recommend you do so now because it's going to come in handy. So I'm actually going to rewrite that chart at the top of my page. And you'll notice on my chart, I go all the way up to 15. You should have those memorized by the time, let's say, Wednesday comes around. Okay? So make sure that you're trying to memorize those. All right. Our goal here is to estimate which two consecutive integers a radical lies between. Now, when we do this, we're going to want to make sure that we're looking at our chart. That'll help us at first. And then eventually you're going to just think about those perfect squares in your head. So, for example number 1, we have the square root of 54. So we're going to look at, we take the 54 and we look at those perfect squares. And 54 would lie right here in between 49 and 64. So the square root of 49 is 7, the square root of 64 is 8, so the square root of 54 must lie somewhere in between the numbers 7 and 8. So the square root of 54 is between the consecutive integers 7 and 8. Okay, example number 2, what if we went ahead and made that negative? So let's do negative times the square root of 102. Well, really all this is saying is that I want to go ahead and multiply this number by a negative 1. So I'm going to find where 102 lies on my chart, and 102 lies right in between 100 and 121, which is between 10 and 11. But since it's negative, I'm going to go ahead and multiply both 10 and 11 by negative 1. So my consecutive integers are negative 10 and negative 11. And last but not least, the last problem you might see or come across, what if we took the square root of negative 24? Now, your natural instinct is to say that 24 is right here in between 16 and 25. However, you look at this problem a little more closely, and you notice there's an issue with it. That negative underneath the radical sign is not allowed. This is actually an imaginary number, so we're not going to go ahead and estimate which two consecutive integers the radical lies between, because it's not an integer at all. It can't be between two integers. So this one is not possible. So you can write a little 0 with a slash through it. That lets me know that this number does not fall in between two consecutive integers. And that's it for the day. So I have a fun fact for you. Actually, it's more like a trivia question. I want to know who can tell me which two Disney movies are the only Disney movies where both parents are present and do not die throughout the movie. There's only two, which is kind of somber, but there are only two. So see if you can think that one out, and good luck with your